So the following here is a logarithmic equation. And if we notice, we've got logs on both sides of the equal sign, both sides of the equation. So my best advice here is to get all your logs on one side of the equation. So I don't want to work with any kind of negative stuff, so I'm just going to add the log here. So adding the log of x, adding the log of x. Okay. Now, by the laws of logarithms, well, before we get to that, this cancels out there. By the laws of logarithms, when we have two logs that are being added, what does that work out to be? Well, that works out to be a product of the insides of the logs. So it looks something like this. So it's suppose x times x plus 3, and then we can say equals 1. Okay, so now let me go ahead and adjust this so we have something to work with down here, a space at the bottom. So now we're dealing with this. So we went from log of x plus 3 plus log x to log of x times x plus 3 equals 1. So now we want to get rid of this log, and we think about it for a second. Well, how can we get rid of the log? Well, there's no base written here. So this right here is the common log base, the common logarithm, which is a log of base 10. So what gets rid of a log? Well, a base of 10. But what you do to one side, you have to do to the other. So 10 to the log, that gets rid of itself, leaving us with x times x plus 3 equals, and 10 to the first power is simply 10. So I'm going to do some simple distribution here. And I'm going to say, okay, well, this is x squared plus 3x equals 10. And now I've got a quadratic. And so this is quite interesting. So let's go ahead and move up just a little bit more. Okay, now I've got a quadratic that hopefully I can factor. Let's take a look. X squared plus 3x minus 10 equals 0. So let's see here. I've got x squared plus 3x minus 10 equals 0. I've got, let's see, factors of negative 10 with a difference of 3. That would be 5 and 2. So I'd say it's probably going to be x plus 5 and x minus 2. Because this right here, 5 minus 2 is 3. And 5 times negative 2 is negative 10. So this gives me here x equals negative 5 and x equals 2. So what we're going to do is let's go ahead and check this out. Because we have two possible solutions, that doesn't mean that they are solutions. So let me go ahead and see what I can do. Let's move my... Oops, 1 second. Move this up right here. I've got two possible solutions that I need to check. And I'm going to actually refer back to my original equation, which was log of x plus 3 equals 1 minus log of x. Okay, now an important thing to note before we proceed is that we cannot take the log of a negative number. So if we end up, we can have a negative number as an answer for x, but if when we plug in x inside the log we get a negative number, then it couldn't be the answer. You cannot find the log of a negative number. It's just a rule here. So remember that. So let's check here. X equals negative 5. I'll put that right there. Let me maybe circle this and come back. So log of negative 5 plus 3 equals 1 minus log of negative 5. And right now you should start seeing negative 5 plus 3 is negative 2. And then this is negative 5. So remember what I said. You can't take the log of a negative number. So what we're going to go ahead and do, this doesn't work. X equals negative 5 doesn't work. And we're going to move right along. Now let's check x equals 2. Okay, so we're going to say log of 2 plus 3 should equal 1 minus the log of 2. Okay, so this is basically the log of 5 should equal 1 minus log of 2, and let me move that up for you just a second. Now we're looking at this right here, and give me 1 second, move the page up instead of the text. So we move that, and we get, if you evaluate log 5 on your calculator, you get something along the lines of 0.699. And 1 minus log 2, you also get about 0.699. So both of these sides equal out, and therefore the only solution to this logarithmic equation is x equals 2. So in some instances, there could be two solutions. There could be one solution, or there could be, no solution, I guess. And perhaps, I guess, based on the degree of what you have inside the log, there could be more than two solutions. But in this case, for this problem, there is only one solution. So you need to go back and check your values for x to see if they really do satisfy the log equation here. So just be very careful with that. Well, good luck in solving logarithmic and exponential equations.